Hey guys, welcome. My name is Artur and today I would like to show you how you can mint your very own NFT using ERC1155 smart contract. So for those who might not know, ERC1155 is a standard for creating smart contracts that can hold information about fungible and non-fungible tokens. I think it's quite popular standard. It's currently supported by all major marketplaces. So at the end of this video, I will show you that you can deploy your very own NFT and then just use it on the OpenSea. So here we have the code of our smart contract. This is the Remix IDE. If you are not familiar with it, I highly recommend you to check some of my previous videos in which you can find the description how you can write the smart contracts here. So I will not cover the basics of it right now, so you can get back to this video, and right now I will just show you how to mint your own tokens. So we have here the contract, and the contract is called game items, and right now we want to extend this smart contract. So this smart contract is ERC1155, and of course we can go to the docs, we can check the code of the smart contract and just copy it here, or better, we are able to just import the library inside our Remix IDE. So we can type here import, and then we can just import some smart contracts, some Solidity code from the GitHub. And here we have the GitHub of the organization called OpenSea, and this organization has well-tested and standardized contracts. So if something is in the repository of the OpenSea, you can be sure that all the code there is audited and checked by the crypto community. So here we can import the contract, which is the ERC1155. Of course, if you do the import, then you would see here that inside the workspace in the Remix IDE, you have the access to all stuff that you are using. So you can just check the stuff that you have here, like token, ERC1155, and here you can actually check the implementation of these smart contracts. So everything is available for you here. However, right now we will just focus on our simple smart contract, so we don't have to bother with the code. And whenever we have the contract like that and we want to take the code of the ERC1155 into our contract, we have to inherit from it. So it's like in object-oriented programming. Here we are inheriting our contract, and here we will specify some constants, which would be just variables, that for instance Charizard is 0, Ivysaur and other Pokemons have other IDs. So this would be just for testing, so we can see that okay, the NFT with the ID 0 is actually Charizard, and the other IDs are different NFTs that we will mint. So we have the contract, and the game items is ERC1155, and right now we have the constructor, and here we are just minting, because in the crypto blockchain world, whenever you create a new NFT, it's called mint. So here we are using the function which actually is implemented inside the standard of the ERC1155, and inside the constructor we are minting 4 tokens inside, and one token is Charizard, the second one is Ivysaur, and here we are specifying how much initial amount we want to have of the specific token. So we're gonna have the smart contract which holds information about 4 NFTs, and the first NFT is Charizard. It has 100 copies, and we have also 3 other Pokemons which are represented with that we have here 100 copies. And here is interesting thing, just deployed to the IPFS, and IPFS is a decentralized storage which I will cover in some other videos on this channel. So usually the NFTs are represented just by the JSON. So we have here on the IPFS my directory, and this directory holds information about the token that has has the ID 0, and here is just the JSON which represents some attributes of our NFT. And the NFT has ID 6, has the name Charizard, and the image of the token. So any marketplace or anybody in the decentralized network can just check the meta file of our token and just get this data and use it, for instance, on the marketplace, which I will show you in a minute. So we have here the 0. Under 1.json we have different Pokemon, and right now whenever we deploy the smart contract, then this constructor will mint for us 4 tokens. And right now let's see what will happen if we just save the file, and then we can try to deploy it. First I will deploy the contract into the memory, so I will just have here the environment JavaScript virtual machine. Here you have to be always sure that you are deploying the right contract, because you can see that we have some smart contracts from the OpenSea, and the common mistake is that people are deploying, for instance, the code from the OpenSea contracts. However, we don't want to deploy something from the GitHub, we just want to deploy our contract, because here we have the constructor and here we have the information about the Pokemons that we want to actually mint. So if I click here deploy, then you would see that you have the deployed contract here, and you can see that we have some functions that are actually not implemented in our code, but they are implemented in the ERC1155. So I will copy the address of the owner of the smart contract. So this address deployed this smart contract, and here we can just type the address, provide the ID of the token, and if we click call, then we see that, okay, this address has 100 copies of that. And let's copy some different address, and I will copy here the different address. And of course, if we would call it, then you would see that we don't have any NFTs for that owner. So only the minter right now have the 100 copies. So let's try to actually send some copies, because obviously we want to have the NFTs not only to have them, but we want to, of course, transfer them. So right now we can just select that, okay, we want to send it from this guy to, for instance, this address. We can copy it here. We can specify that we want to move the token with ID 1, and we can specify that we want to send 15 copies. Here in the safe transfer form, we can also provide the data. I will use here some garbage because we are not using the data for anything. And you can see that if I click transact, then we're gonna transfer the 15 copies from this address to that address. So if we're gonna check the balance right now, you see that after running the safe transfer from, this address holds just less copies of the Pokemon. And of course, if we take this address and check it again, then you would see that this guy has the 15 copies of that token. So that's very easy, right? We have the ERC1155 smart contract, and we are able to check some information about who is owning what, basically. However, we have also the built-in function, which is called URI, and if we provide here the token ID 1 and just use it, then you can see that we have the string which returns us the address under which we can check the information about the NFT. However, this format is not supported by OpenSea. So OpenSea wants to have the URI function to which you are passing 1, and then the OpenSea gets basically the URI under which they can find information about the certain NFT. So right now we're gonna override the URI function so it works a bit different. And in order to do that, we're gonna need helper functions to work with the strings. And then once we have the strings util imported, then actually we can override the function. So right now we are writing the own implementation of the URI function, and we want to take the token ID, and then we want to concatenate first the base URL. So this is the URL to my directory on the IPFS. It can be any domain in the internet. And here I can provide that, okay, I want to change the integer to the string. So that's why I had to take this library, and I'm able to change integer into the string, and then I can use abi.encode and pact, which will just produce the concatenated string. So instead of here just id.json, I would see the past parameter. So it works on the OpenSea. So right now I will just save it, and we don't need the old version of this smart contract. Of course, we want to recompile it and deploy it again. And if I deploy it again and use the URI function, here you see that now we are having the URI that is actually supported by OpenSea. So this means that we can try to deploy our code into the test network. So I'm gonna use my MetaMask wallet on the Rinkeby test network, and here I have some test account that we're gonna try on the OpenSea. And OpenSea is a marketplace where you can just put any of your tokens and trade these tokens and with other users. So we want to put our smart contract into the testnet so OpenSea can grab it. I will use the injected Web3. Here I will make sure that I'm in the Rinkeby test network, and right now you can see that we have here the Rinkeby network, and we have exactly the same address that I have here inside the MetaMask. And now I can click deploy, and now we are not using any longer JavaScript virtual machine, we are using the test network, and we can just click here the confirm, and after some minute our smart contract would be deployed into the network. So you see that right now we have again our smart contract deployed, and this address is, here is the address of our smart contract. So after deployment, the smart contract is on this address, and this address is of course inside the Rinkeby test network. So let's go to the OpenSea, and right now I'm logged in as this user into the OpenSea, and if I refresh, now we would need to see that we have some NFTs, and of course it takes time for OpenSea to take that information, but you see that we have here the address of this smart contract. So here we have the smart contract address, and you can see that we have the token ID with the 0, and if we change it to 1, then you can see that we have also information about the IVs hour. So this is our smart contract, which holds information about NFTs, and we have here, for instance, the Charizard. The Charizard has the token ID 0, and we can see that this token is owned by me, and I have 100 copies. And if we do some transaction completely outside of the OpenSea, like here we can use the safe transfer from, and let's say I want to use my address and I want to move it to completely different address. For instance, I would take other test account here, so I will change it, and here I will move the Charizard, and I want to move 10 copies, and I want to put here nothing. And now I'm again asked by the MetaMask that if I want to move my token, and now the token is moved, and let's see what happens here on the OpenSea. And OpenSea of course needs a bit of time to synchronize with the on-chain data, because right now we just created the transaction that was sent into the Rinkeby test network, but here the OpenSea is interacting directly with the blockchain network. So they are relying on the information that is written on the on-chain. And now you see that I'm owning actually 90 copies. The 100 was total, and the Charizard right now is owned by 2 people. So it's the one address that I minted the NFT originally, and this is the second address. So right now you know that you can very simple way deploy ERC1155 smart contract using even your web browser. You just have to customize how the URI function from ERC1155 smart contract works, and then after just small adjustment, you can start using your token on the OpenSea or any other decentralized marketplace for the NFTs. So if you are interested in NFTs, just paste some questions down below, or let me know what kind of NFTs you are working with. If you have some questions about decentralized storage and how to store metadata about your NFTs, you can also ask questions down below, because right now I'm preparing some new stuff for this channel, and I would like to cover some more advanced stuff with the NFTs and show you how you can mint the stuff not from the Remix IDE, but from your JavaScript code. So if it's something interesting to you, let me know, and thank you for attention, and see you on this channel.